Hi and welcome to this onmaths prediction for the AQA Paper 2 Foundation Tier Maths GCSE. Enjoy! Hi and welcome to this prediction video from onmaths. Now what this prediction is we look at all the previous exam paper questions and see what comes up regularly and what's long overdue to come up and create this predicted paper. You can do this predicted paper online for free if you click up here. And on our site also is Topic Busters, which is basically just specific topics with all the questions based on those. And we've got Topic Busters for every single topic. And you can also check out the Revisionator, which is quicker and shorter blast of random questions to help you revise. You can sign up for free. In fact, everything on our website is completely free. Please make sure that you use this as part of your normal revision. Don't just fully rely on this paper because it is a prediction. You need to just use this as a revision tool amongst all your other revision stuff. Don't forget also that when you do this online, the numbers will be different. The methods and questions will be the same, but the numbers will be different. So you can do it multiple times to see if you improve. I hope you enjoyed this video, and if you do, please click like. And if you want to see more from us, please click subscribe. Thank you very much. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here. And then we've got another diagonal one here. So it has 4 lines of symmetry. You will need to be familiar with the names of 3-dimensional shapes. So the one we have here is a triangular based prism. So a prism is a shape that you can cut anywhere along one of the axes. So anywhere along here, and it would look exactly the same. It would look like a triangle. The first bit of this, triangular based, is just the name of the shape at the end, the name of the shape at the end of the prism. So you can have a hexagonal based prism or anything like that. It says write down the number of faces. So the faces we can see, well, the face we can see here is a triangle, so that's 1. Then we've got one along here, which is a rectangle. So we've got 2 that we can see, but there is also going to be a 3rd one round here, which is also going to be a rectangle, a 4th one at the bottom, which is going to be a rectangle, and then a 5th one round the back, which is going to be a triangle, just like number 1. So in total there are 5 faces. Try and remember what a face is. A face is something you can lay your hand down flat on. An edge is something that you can run your finger along, so that's an edge there. And vertices, or vertex, is something that if you put your finger on, it would be pointy. So there are going to be 6 vertices. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger. This is our units column. This is our tenths column. And this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths, and that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660, and the next one down is 650. So those are the 2 it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. If I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think, personally, it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says what day are the most DVDs sold, Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2 3/4. So it's definitely going to be Monday because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there and you've got the 8 there. Now we've got a bit of a problem here because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put one circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in, 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. So we're given function machines for this question, and it says what is the output when the input's 24? So the input's 24, and the first thing that's going to happen to it is it's going to divide by 2, so we're going to halve it. So that's going to make it 12. Then it says we're going to add 6. So when we add 6 to 12, we get 18. So the output is 18. Next question says below is a different number machine. It says when the input is 20, the output is 56. So let's follow through on the input. So the input's 20, we go take away 6, so that's going to give us 14. Now we've got to then think, right, how do I get from 14 to 56? Now, as it stands, there are multiple ways of doing this. If you do this on onmaths.com, it has a drop-down box and it only lets you select one of the options. So you can add a number to 14 to get to 56, and for this question that would be full marks, that would be absolutely fine. Or you can times it by 4, and times by 4 is the one I'm going to go for. So I'm going to complete the number machine by saying times 4. Alright, so the first place to start on this is to plot the points. So point A is at -3, -2. So along the corridor and up the stairs, well, we're going across -3 on the x-axis, which is this one here, and then we're going to go down 2 on the y-axis. So it's this one here. A really common mistake is to muddle them up. So as long as you remember you're going across and then up or down, obviously if it's negative you go down, then you should be fine. Now it says point A, so I probably should label that as A. And point B is 0, 3. It means we're not going left or right at all. We're just going to stay at 0, but we could go up 3. So it's going to be there. And point C is at 3 -2. So along 3, down 2. Which could be that one there. So that's point C. And it says plot and join these coordinates. So I'm just going to get my ruler and plot and join them. Well, we've plotted them, so we're just going to join them. And there we go. Makes a nice little shape there. Now, question B says, what type of triangle is ABC? So, looking at it, it looks like this length here and this length here are exactly the same length. So, when we've got a triangle with 2 sides the same length, it's an isosceles triangle. And try and learn the spelling of isosceles, because it does look better when you spell it right. I remember it's ISOSCELES. The SOS is like a Morse code thing to get help, save our souls. So I've always remembered SOS, as in, oh my goodness, I don't know how to spell isosceles. Okay, so this is a football team's 30 games and how many goals they scored in them. And it asks us for the total number of goals the team scored in the season. So in 2 of the matches, they scored 0 goals. So the first box, they haven't got any goals at all. 3 of the matches, they scored 1 goal. So they've scored 3 goals 3 goals in those 3 matches. In 8 of the matches, they scored 2 goals. So that's 16 in total. And all I'm doing here is timesing these 2 together. 12 matches with 3 goals, so that's going to be 36. And in 5 matches there were 4 goals, so that's 20 goals in total. Now in total, we're going to add those together, so 3 plus 16 plus 36 plus 20, which is 75. So they've scored 75 goals in total. Now the next question asks us for the mean number. Now the mean is all the numbers added up, which actually we've already done, 75, divided by the total amount of numbers. Now we could add up this column here, but actually it tells us in the question that there are 30 games, so I know they'll add up to 30. So we're doing 75 divided by 30, and it says it wants it to 2 decimal places, but actually this one will give me the answer of 2.5. So I could leave it as 2.50 if it needs it to 2 decimal places. Okay, so we're asked for all the possible combinations of sweets. The important thing here is to be methodical whenever you are asked a question like this. So I'm going to start with the first one and pair it up with the second one. And I'm going to keep with the first one, which is apple, and pair it up with the third one. And then I can't do any more with apple because I've got both the combinations down. So I'm going to move on to the second one, which is banana, and pair it up with coconut. And those are the 3 options. So with these types of questions, just make sure you have a nice routine. And you'll normally have items that have a different first letter. So it's just a bit easier to write them down. Rather than writing apple, I just write A. And that's absolutely fine. With any sequence, the first thing to check is whether it goes up by the same amount. Well, looking at this goes up by 1, this goes up by 3, so it's not going up by the same amount. This goes up by 4, this goes up by 7. But something you might notice is this goes up by 7, and yet there's a 7 here. This one goes up by 4, and there's a 4 here. This goes up by 3, and there's a 3 here. This is what we call the Fibonacci sequence. So the Fibonacci sequence just starts off with 2 numbers, and then we add the previous 2 terms to get to the next term. So we'll add these 2 together to get to the next one. Then we add these 2 together to get to the next one. So to find the next one, we need to add the 11 and the 18 together. 18 plus 11 is going to be 29. So the next term is going to be the 29th term. Let's just check that's the 6th term. 1, 2, 3, 4, 5. So yes, that would be the 6th term, would be 29. Then we need to add the 18 and the 29 together. And when the numbers get big, if it's not on the calculator paper, you can just add them like this. So 9 plus 8 is 17, and that's going to be 3 plus 1, which is 4. So it's going to be 47. So the 7th term is going to be 47. So always just check that the sequence isn't a Fibonacci sequence before you start to panic and think, what is this sequence? Always check for a Fibonacci sequence, which is just that the previous 2 terms are added together to make the next term. Okay, so this is quite a tricky question. So we've got a set of axes and we're given a line on it, and we're asked to find the equation of the line. So let's have a look at this line. At every point on this line, okay, even points between the lines, at every single point, x is continually changing. If we have a look at the x values, they continually change. So x is a variable, x will just keep changing. But if you have a look at the y is always 3, anywhere on that line. So the equation of the line is y equals 3, because y is always 3 anywhere on that line. So horizontal lines are always going to be y equals something, and vertical lines are always going to be x equals something. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. This question is just asking you to work out 13% of 2,680, then work out 8% of 3,114, and then write down which is the biggest, okay, which person gave the most. So first of all, we want to do 13% of 2,680, and since it's a calculator paper, then we can do that by just converting the percentage into a fraction. So percent means over 100, and timesing it by the amount. So on my calculator, I will do 13 over 100 and times that by 2,680. And it might give you a fraction, just press the S to D button, and that gives me 348.4. And in money, that's 40, because obviously we do 2 decimal places for money. And I haven't shown the examiner who that is, so I'm just going to show the examiner that that's James we're working out. So on to Paul next. So we want 8% of 3,114. So we're going to do 8 over 100 times 3,114. So fraction button, 8 over 100. Or we could do 8 divided by 100. Gives you the same answer, 3,114. And that's going to be £249.12. So obviously James gave the most because that's the biggest number. So my answer will be James. And it says who gives the most to charity and by how much. So we need to work out by how much. So 348.40, take away 249.12. So 348.4, take away 249.12, and that gets me 99.28. So it's £99.28. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? Where it says in total, they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food, it's 39. And for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what one part is worth. So one part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each one part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here. And the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts, so we're just going to write drink. So if each one part's worth 277, we're just going to do 4 lots of that. And I might as well do it on the calculator, times by 4, and that's going to be 1108, so 1108. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get 1 tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get 1 tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's 1 done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much 1 tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out 1 tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42 because that one moves up. The 20 tissue box is 34.45, and the last one is 35.87 because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it, and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, for this question we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T and fudges, the amount of fudges, to be called F. So instead of 2 toffees we have T toffees, and instead of 3 fudges we have F fudges. And in algebra, we always put the number before the letter and we don't show the time sign. So it's 50t plus 70f. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5t plus 0.7f. So the answer is C equals 50t plus 70f. And that can be either way around. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to 2 significant figures. Now, to do 2 significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400, okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now, we've got to work out what the sizes of them are going to be. Well, the top one's easy. It's just 7 centimetres by 6 centimetres. Now, I'm not going to be able to draw this accurately because I don't have a ruler. But we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimetres, and that should be 6 centimetres. And in your exam, just make sure you actually measure them because they are said to you in here, and it does say accurately construct. So you want to make sure that it's done 7 centimetres and 6 centimetres. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here. But what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimetres left over. So it's going to be 2 centimetres in width. Ooh. Let's use this one, right. So it's going to be 2 centimetres in width. So 2 centimetres there. And this one obviously is going to be 6 centimetres, the same as the right hand one. Now this line we have in the middle, this line here, is really important because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. First thing we need to realise with this question is which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2. I need to go 2 left. So 2 left. And let's have a think. How much up do we have to go? So 1 jump, 2, 3, 4. So 4 up. Now the way of showing translations is by using vectors. And it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. Okay, so the first thing to do with this question is realise that x is sandwiched between -12 and -5. And all we need to do now is figure out what the sign's going to be. So x is going to be greater than -12, but it's also going to be equal to -12 because this dot here is filled in. X is smaller than -5, but it can't equal -5 because this dot here is hollow. This question doesn't ask you to show the reasons for your working out, however most of the questions will, so let's try and make sure we write down some reasons as we go. The first one I'd go for is this one here, which I'm going to call A. Now I know that A is 180 take away 115, so 180 take away 100 is 80, take away 15 is 65 degrees, and the reason is it's angles on straight line. And if I know A, I know that B as well. So B is going to equal 65 degrees as well, because it's an isosceles triangle. All the bottom angles in an isosceles triangle equal, assuming that the isosceles triangle has the two same sides on the left and right. Obviously if it's rotated it's not the bottom two angles, but it's always going to be these two angles here. Okay, so B is 65. Now I can go straight to X. Because these are parallel lines, X and B create a Z angle, and we need to figure out what the Z angle is called, but we're going to say X is 65, it's the same as B. Now corresponding is the F one, interior or co-interior or allied angles are the C ones, so the one we've got left is alternate. They're alternate angles, they're Z angles. So the answer I can write is 65 degrees. Okay, so whenever we're asked to estimate with a scatter graph, we're always going to start off by drawing a line of best fit. So I'm going to draw my line of best fit, and yours might be different to mine, and that's absolutely fine. Now it's asking us to estimate the height, and it's giving us the width. And that's really important because the width is up the side. So a common mistake would be to read 17 from the bottom, but the height is at the bottom. So we've got to check the scale first, and it seems like it's going up in 2s. So let's just check that. Yep, it's going up in 2s. So what I want to do is draw a line across at the width of 17, which will be roughly here. I'm going to stop when it hits the line of best fit, and I'm going to draw a line down. And I'm going to read off what that is. Well, this scale is also going up in 2s, I think. Yep, it is. So the estimate of the height would be 4 centimeters. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3 over 19 on the calculator, but we know that that's going to be 16 over 19. So we can kind of ignore Denver now, because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5 to 2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part, is going to be worth, well, as a fraction, it's 16 over 19 divided by 7. So 16 over 19 on the calculator divided by 7, which gives us 16 over 133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32 over 133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question, because it says grams, which is mass, per centimetres cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that, but we haven't got the volume. So the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So it's the area of the triangle. We've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9 times 10. Now the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles, and don't forget to halve it. Now what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimetres cubed, because every unit is in centimetres, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1,800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. So when you have a right angle triangle and you're given 2 of the lengths, and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are two methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method, because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with three steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step, it's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its two decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle two we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now, this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Okay, I understand the temptation in this question to say that the answer is 0. Please do not write that. Anything to the power of 0 is not 0. Anything to the power of 0 is 1. Now you can think about this. If you do x to the power of 5 divided by x to the power of 5, then the rule is that you take away the indices when you divide them, so it's x to the power of 0, and we know that any number divided by itself is always equal to 1. So the answer to this question is always going to be 1. Just try and remember that. Anything to the power of 0 is 1. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is we want to do, I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. what's the percentage increase? Now percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617 blah blah blah. So that's to the nearest percent, so that's going to be 67%. Now I'm going to be using the multiplier method for this question. If you've got a different method that works really well, then stick with it, but you do need to know the multiplier method for the GCSE. Now the word that probably tricks most people is this one here. Depreciates means goes down. Okay, it means it loses value. So it goes down by 1.7% each year. So to work out the multiplier, you first of all start off with 100%. Now this time you take away 1.7%, okay, because it's going down by 1.7%. And you can do that on your calculator or in your head. So 100 take away 1.7 is 98.3%. Then you want to work it out as a multiplier. So you're going to do 98.3%, and you just divide it by 100. And multiply is a posh way of saying decimal. So 0.983. Now, anytime I times something by 0.983, it will decrease it by 1.7%. So we've got a car we bought in 1980, and what is it worth in 1985? So that is 5 years. So it's going to depreciate by 1.7% every year. So we've got the 2,245, and if we times it by 0.983 once, that's 1 year. But we need to times it by that amount 5 times. And instead of writing that times 0.983 times 0.983 times 0.983 5 times, I can just do it to the power of 5. You get the same answer. So in the exam, you can just write times 0.983 5 times, and that's absolutely fine. You get the same answer. So 2245 on the calculator times 0.983 to the power of 5, and I get the answer of 2060.553687 blah blah blah. Okay, so because it's money, it's going to be 2 decimal places, so that's going to be 55. Now last thing is just to check your answer makes sense. Well, the car was worth 2,245. It has depreciated, but not by very much. 1.7% is not very much. So it's gone down, and it's lost about, say, roughly £200. So the answer makes sense. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's to the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side
and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here.
I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.